All right, you should have your notes out in front of you, pen or pencil to write with. Make sure your name's in the top corner and what period you're in. But we're going to talk about inequalities. We're going to lay the foundation for what they are, how we use them, and how we solve them. So make sure you're set up and ready to go. All right, there's your first part right there. An inequality is a math sentence that compares quantities. An inequality is a math sentence that compares quantities. That is basically our definition as well. It's a math sentence showing that two things are not equal. Two quantities, two things are not equal. All right. We've been dealing with equalities and equations for a while, but now we're talking about inequalities, and these are things that are not equal. We've probably seen some of these signs before. All right. The greater than sign, the less than sign, the greater than or equal to, and the less than or equal to sign. These are the symbols of inequalities. So we're probably familiar with those, but that's what we're talking about. Math sentences showing that things aren't equal, and there are symbols that we are familiar with. All right. Examples of inequalities. Well, 2 plus 3 is less than 10. That's a clear example because we know that's 5, and it's definitely less. Things are not equal. We also have another one. We can use variables. 6 plus x is greater than 13. There are values that would make this true. Okay, so that's another example of an inequality. Okay, things are not equal. Then there's also non-examples, meaning things that are not examples of what we're talking about today. Notice both of these have equal signs. 2 plus 3 equals 5. And then 4x equals 24. Remember, that means multiply 4 with x, and you'll get 24. So notice, equal signs, those are not inequalities. Over here, when you see the inequality symbols, that's what we're talking about. All right, some examples in context here. Let's just look at some of these real quick. Let's see. All right, so let me use my pen feature here. Switch to red. Cost to download 10 songs is greater than the cost to download 2 songs. That is probably the case. The outside temperature in summer is greater than the outside temperature in winter. Okay, we're just using symbols to show which one's greater, which one's less, whatever. The height of a first grade student is less than the height of an 8th grade student. Okay, we're going to assume normal development that that's true. And the fourth one, the time spent eating lunch is hopefully that's greater than the time spent brushing your teeth. Okay, hopefully you have more time to eat lunch than it takes to brush your teeth. All right, so we're just getting started with inequalities, but if you need more time, pause the screen because I'm moving on to the next part now. All right, those symbols we talked about, okay? There's the greater than symbol. Let's start with that one. The greater than symbol in word form, we know that's the greater than symbol. Okay, that's the words of it, greater than. And here's an example. 8 is greater than x. All right. We don't know x's value, but we do know 8 is greater than it in this example. So there's our first symbol. Then there's the less than symbol. Okay. The mouth is facing the right. That's the less than symbol. Okay, so there's your words. And there's an example. S is less than 5. So we're just showing a value of something that's not equal. Something is less than something else. We have the greater than or equal to symbol. Notice the only difference now is that there's an equal sign or like a partial equal sign underneath the greater than part. So we would say that that is the greater than or equal to sign. And we can give an example here that W is greater than or equal to 9. That means it could be either. It could be greater than 9 or it could also be equal to 9. Okay, so W might be 9 or it might be something greater than that. But it's definitely at least 9. Okay, so there's just an example of that one in context. Then there's a less than or equal to symbol, the fourth of the inequality symbols. And there's an example right there. 7 is less than or equal to y, right? 7 is less than or equal to y. So those are just examples. Those are the words that we would use when we see them. And that part I think you're pretty comfortable with most likely because it is pretty straightforward. All right, now let's talk about inequalities in context. All right, inequalities can be solved by finding values of the variables that make the inequality true. We can actually work with inequalities because sometimes the values will make them true and sometimes they won't. So we're going to kind of establish what's going on here. So for example, one of the numbers 6, 7, or 8, which of those is a solution to the inequality x plus 2 is less than 9? So that in the blue circle is our inequality. We're going to kind of substitute those numbers in the green circle in one at a time and see which ones make it true. Maybe they all do, maybe none do, maybe one of them does, whatever. So let's just kind of jump along here. All right, so the first thing we're going to do is we're going to write the inequality in all three of those top boxes. Okay, start with the most important thing, the inequality. X plus 2 is less than 9. That's what we're working off of. Okay, so put that there. And once you have that there, now we're going to substitute those numbers, 6, 7, or 8. We're going to start with 6. So let's go to that very first column. And we're just going to plug 6 in for x. 6 plus 2 is less than 9. If we actually solve that, that's 8 is less than 9. And that, my friends, is a true statement. All right, that's true. When 6 is substituted for x, our inequality is true. That's how we would talk about it. Let's try 7 now. Okay, if we plug in a 7 for x, well, then we get 7 plus 2 is less than 9, and we solve that, and that's really 9 is less than 9. And that doesn't look right because it's not true. All right, 9 is not less than 9. So 7 is not a solution for this inequality. 6 was, 7 is not. Let's look at 8. 8, when we plug it in, 8 plus 2 is less than 9. Well, that doesn't add up, right? I mean, 10 is not less than 9, Mr. H. I know that's not true. So 8 is also not a solution of the value for x. Okay, some values work, like 6. Okay, but some others don't, like 7 and 8. So we would say, since 6 is the only value that makes that a true statement of the ones they asked us about, 6 is a solution of the inequality. That's how we talk about it. Okay. All right, let's keep moving along here. Now there is, okay, example 2. First of all, I want you to copy the inequality that they give you in that inequality. N minus 3 is greater than 6. Copy that in the top box. And then I want you to substitute the values that they give you of the numbers 8, 9, or 10, which is a solution. So you're gonna solve those there, okay? You're gonna solve those to see if 8 works, if 9 works, and if 10 works. When I say if it works, does it make it true or does it make it not true? So pause the screen, give these a shot, and then turn it back on when you're ready to check. All right, hopefully you've given these a good effort, but you can see that when we substituted 8 in there, it is not true because 8 minus 3 is 5, and that is not greater than 6. Same thing when we plug in 9 for n. 9 minus 3 is 6, and that is not greater than 6, so it's not true. The last one, though, 10 worked. 10 minus 3 is 7. That is greater than 6. So we would say 10 is part of our solution set. Okay, it worked. It made the inequality true. So that was the only one of these three that was true. All right, here's what I want you to do now. Okay, I want you to finish out this part right here. Okay, follow the directions, read the problem, and just make sure you're kind of doing it step by step. But you're trying to see if something is a solution of the inequality, like if does this work? Does y equals 6 work? And then does x equals 8? Does that work? Okay, show your work on that part. And then also on this part right here, I want you to also try these. Okay, I want you to try those 6 problems and you're deciding if it's true or not. And when you are done, bring it to me so I can check and see that it was all good. Actually, you're doing 6 problems, not 3. All right? So do all 6 of those, bring it to me when you're done. I can check and then either help you or just tell you, hey, good job, you're doing it right. All right, there we go.